Have you ever typed something into a tool like ChatGPT and just been completely floored by the answer? I mean, it really feels like magic, doesn't it? Well, today we're going to pull back that curtain. We're going to demystify the one piece of tech that's really behind this entire AI revolution. Okay, let's get into it. So check this out. This quote is from an experiment with GPT-3. Someone asked it to write a story about a pie creature, and this is part of what it came back with. Now, just stop and think about that. The AI didn't just write some random story. It inferred that a creature named after a mathematical constant should probably live in a world of math. I mean, how on earth does a machine make a creative leap like that? And that, right there, is the big question. How can a machine do this? I promise you, it's not magic, and it's definitely not some conscious minds living in the cloud. Nope, it's a really, really clever piece of engineering, an invention that literally changed everything. And it all comes down to one thing. The transformer. This is it. This is the engine. It's a special type of neural network that is just unbelievably good at understanding one thing: context. And to really get how it works, we're going to follow a single sentence, a single prompt on its amazing journey right through the heart of a transformer. And that journey, it basically has 4 big steps. First, our human words have to get turned into numbers. Second, those numbers need to soak up the meaning from all the words around them. Third, the network does what you could call some deep thinking. And finally, it makes its best guess for what word should come next. Sounds pretty straightforward, right? Well, let's start at the beginning. So first things first. Before a transformer can do anything, it has to translate our language into the only language it understands: math. Because, you can't really do calculus on the word apple, but you can do a ton of it on a long list of numbers that represents apple. Okay, so the process kicks off by chopping your sentence up into little pieces called tokens. You can think of them as words, or sometimes even just parts of words. Then, for each token, the model looks it up in this gigantic internal dictionary and assigns it a special list of numbers. This is called a vector. And this isn't just a random list, oh no. It's like a coordinate, a point on a giant map of meaning. It places that word in a vast, multi-dimensional space where words with similar meanings are located close together. And this is where it gets really wild. This meaning space isn't random at all. It has structure. Directions in this space actually mean something. The classic example is this. If you take the vector for king, and you subtract the vector for man, and then you add the vector for woman, you land almost exactly on the vector for queen. The model has learned the concept of royalty and gender all on its own, just by analyzing text. It's mind-blowing. So how does it learn all of these incredible relationships? Well, it's through a number of parameters that is just staggering. For example, the GPT-3 model has 175 billion of them. You can think of these as 175 billion little knobs and dials that the AI gets to tune and adjust during its training. That's how it builds that incredibly detailed map of language we were just talking about. Okay, so now our words are numbers, and they're floating around in that meaning space. But the meaning of a word can change completely depending on the sentence, right? Like a riverbank is totally different from a money bank. So how does the AI figure that out? Well, this next part, this is the real genius of the transformer. It all comes down to a mechanism called attention. And this, right here, was the massive breakthrough. See, older models tried to read a sentence one word at a time, and by the end, they'd often forget what was at the beginning. Attention is different. It lets every single word vector talk to every other word vector in the sentence, all at the same time. They're all looking at each other, figuring out which words are most important to which, and they update their own meaning based on that context. So the vector for bank pays close attention to the vector for river, and its meaning actually shifts to become more riverbank-like. It's brilliant. Right after that big attention conversation, all of those newly updated context-rich vectors get sent to another part of the network. Here, each vector is worked on individually. You can almost picture it like the network is taking a quiet moment to think about the new meaning of each word, just processing and refining its understanding before moving on. So you have this whole incredibly complex dance, right? Words become numbers, the numbers all talk to each other, the network thinks about them, and it's all for one single, surprisingly simple purpose: to predict, with the highest possible accuracy, what word comes next. So after all that work, the model takes the final, fully contextualized vector at the very end of the sentence, and it uses that to generate a score for every single word it knows. We're talking tens of thousands of them. So if our prompt was something like, Harry Potter's least favorite teacher is, you can bet that the model would generate a really, really high score for a certain potions master. But these raw scores, engineers call them logits, they're not super useful by themselves. It's just a long list of random-looking numbers. To make them make sense, they get passed through one final function called softmax. And its job is pretty simple. It takes that messy list of scores and turns it into a clean list of probabilities, into percentages that all add up to 100%. And bam, this is what you get. After softmax, our Harry Potter prompt has a clear winner. The model is basically saying, I am 75% sure the next word is Snape. It gives a little bit of a chance to other characters like Dumbledore or Filch, but the context has pointed it overwhelmingly in one direction. The prediction is me. Okay, but hold on. ChatGPT doesn't just spit out one word. It writes whole essays, poems, chunks of code. How does it go from predicting just a single word to creating this long, continuous stream of text that actually makes sense? Well, it uses a simple but honestly a genius-level trick. It's a generative loop. Here's how it works. Step 1. It predicts the next word, just like we saw. Step 2, it picks a word from those probabilities. Step 3, and this is the key, it sticks that new word onto the end of the original prompt. And step 4, it just feeds that new, slightly longer prompt right back into the machine and does the whole thing over again. It predicts the next word, adds it to the end, and repeats and repeats and repeats, one word at a time. Now, when it's picking that next word, it doesn't always have to pick the number one choice. There's a cool setting you can adjust called temperature, and it basically acts like a creativity dial. If you turn the temperature down low, the AI plays it safe. It always picks the most obvious, predictable word. But if you crank the temperature up, you encourage it to take some risks, to pick some of the less likely words, and the results can be pretty amazing. And you can really see the difference here. With a low temperature, a classic starter like Once Upon a Time gives you, well, a classic, predictable story about a princess. But turn that temperature dial up, and you get something way more original and creative. A story about a web artist who dreams of painting with code. It's way more interesting, right? But you have to be careful, because if you turn it up too high, it can just start talking nonsense. So when you really break it all down, these incredible AIs are, at their core, just extremely sophisticated next word prediction machines. They've built this stunningly complex statistical model of human language, but they aren't thinking in the way we do. And that leaves us with a really deep final question. If a machine can predict language so perfectly that it seems to create and reason and even empathize, what does it actually mean to understand something in the first place?